Okay. Okay. So license plate starts with a digit other than 0, followed by 3 capital letters, followed by 3 digits. How many different license plates are possible? Okay. And then part B, how many different license plates start with an 8 and with a 1? Part C, how many different license plates have no repeated symbols? They're all different. Okay. So, when they design license plates, for example, one of many things, when they pick phone numbers, when they do this kind of thing, they have to have a plan that will allow enough variation for all the people that are going to use that. So for license plates, they got to have some kind of system that'll give enough options for all the cars that are going to be purchased, right? So if California said, we're just going to do 2 letters, A, W, and 2 numbers, 7, 6, that probably, I don't know, I didn't calculate it, but that wouldn't be enough options. They'd run out of license plates. Does that make sense? There'd be too many cars. They wouldn't have enough options. So when they do this kind of thing, when they come up with a scheme for license plates or phone numbers or zip codes or different things like that, they've got to make sure they've mathematically calculated that it'll give enough options for everybody that's going to use the thing to have a unique identification. So here's how they do that. This is using probability. So let's say they come up with this plan. States license plates starts with a digit other than 0, followed by 3 letters, followed by 3 digits. How many different license plates are possible with that scheme? It's kind of a weird question, huh? Seems like it comes out of nowhere. Let me ask you this question for starters. What if you have, you're going to dinner, okay? And you can choose the salad or the soup, and then after you choose salad or soup, you can choose the main course, which is chicken, steak, or fish, let's say. How many different ways can you choose your dinner? Well, if you go to some, a wedding rehearsal or something like that, and they have this kind of options for dinner setup. So you can choose the salad or the soup, then you can choose chicken, steak, or fish. How many different possible dinner setups are there? 6. Yeah, 6, huh? It's just 2 times 3 is 6. Yeah, because you can choose salad and then go to chicken, steak, or fish, and then you can choose soup and go to chicken, steak, or fish, huh? 6 different ways to pick your meal plan. So 2 times 3. So you just multiply the number of options for each decision. Do you see that? Let me say that more slowly again. You have 2 decisions to make. Your first decision is, am I going to have soup or salad? And there's 2 options for that decision. Then your second decision is, am I going to have chicken, steak, or fish? There's 3 options for that decision. 2 times 3 is 6 different ways to have your meal, right? You could have salad and chicken, or you could have salad and steak, or you could have salad and fish, or you could have soup and chicken, or you could have soup and salad, or you could have steak and soup and fish, right? Those are the 6 different meal plans you could go through just to be thorough and list them all out. There they are, right? So we see from that basic example that whenever you have several decisions to make and options for each of those decisions, if you want total ways of putting that together, you just multiply those together, right? Total ways of putting that together. So we can do that with the license plate thing. Let me get this out of the way. So with the license plate thing, let's actually do it. This is what I took a whole class on this topic, and I learned one thing I learned was it's real helpful to me if I actually do what it is they're saying. So let's actually pick one. Let's pick one license plate. Ready? I'm going to actually pick one. It says start with a digit other than 0. All right? 7. And then do 3 capital letters. All right? W, X, M. I just picked 3. And then 3 digits. All right? 706. All right, I picked a license plate. There's a particular license plate. Now, think back. I just made a bunch of decisions, right? How many decisions I make? Well, each of those was a decision. I'll put a line there. And for each of those decisions I made, how many options did I have? So I'm doing like the soup, salad, the dinner thing, right? I'm just saying, hey, I chose my super salad, and then I chose my main course. Well, I chose a digit, 3 letters, and 3 digits, didn't I? Let's think about how many options I had for each of those choices. So in my first choice, when I chose the 7, how many options did I have for that first decision? So I'm going to put options on this line. How many options did I have? How many different things could I have done? Like for the soup and salad, that's 2 options. For the chicken, steak, or fish, that's 3 options. So for this first digit, how many different things could I have chosen there? How many options did I have? Almost 10, but you can't choose 0 because they gave this particular rule. You can't start with 0, right? Starts with a digit other than 0. So you can't pick 0, so you can do 1 through 9, huh? So there's 9 options there. You could do 1, 2, 3, 4, 5, 6, 7, 8, or 9. Is that good so far? Times, remember we're going to multiply these all together. Next, I chose a letter. I had to. There were no rules. It was like any capital letter. Doesn't matter. I picked W. But how many options did I have there? 26. Yeah, do you know there's 26 letters in the alphabet? Yeah, there's 26 letters in the alphabet, 26 options. Next, I chose, here, I'll just make this a time so we don't think it's an X or something. Next, 26 options for my next letter, 26 options for me, right? Those were just three letters, 26, 26, 26 options for each of those decisions. Now, next, I picked the digit 7 again. How many options did I have for that digit? There it's 10. Well done. There it's 10. Right, because I can use 0 now. It's 1 through 9 or 0. Everybody with me on that? Right? You could only not use 0 with what you start with, right? It starts with a digit other than 0. But back here they just said 3 digits, 0 through, they even said 0 through 9. Yeah, so that's 10 different digits now, right? Because there's 1 through 9, which is 9, and then throw in the 0. That's 10. Next digit, 10 options again. Last digit, 10 options again. Multiply those all together. Somebody have a calculator? It's going to be a big number. Anybody? Going to have 3 zeros at the back. Anybody got it? I'm going to try here. I'll just get a calculator up. I didn't bring my calculator. So this is going to take 26 times 26 times 26 times 9. So I'm getting 158,184,000. 158 million. You guys getting that? 158,184,000 different license plates. So in other words, that plan will cover that many different cars, huh? There's that many different license plates possible. So, you would look at, the United States or wherever you're making the plan for, say, is that enough? Does that cover us? Do we have more than 158 million cars? I think that probably covers us. So there we go. Makes sense on that? We good with how that works? That's part A, though. That's just part A, huh? All right, let's go on and do part B. Decisions and options is the main thing. So part B now. Let's try part B. Part B says how many different, they have to start with an 8 and end with a 1. Start with an 8, end with a 1. Let me give you a second. Give that a try. See what you can come up with. Start with an 8, end with a 1. How can that work? Give you just a minute. Think about that. So lay out your decision. Same kind of thing, right? In fact, I would actually pick one. Let's pick one, right? Start with an 8, all right? Got to start with an 8. 8, and then 3 digits, right? WTB or whatever. And then you've got to do 3 digits, right? Yeah. 4, 6, and you've got to end with a 1. So there I actually did one, right? I picked a license plate fitting their criteria. So think back to how many decisions. So for each of those decisions, put a line and write on that line how many options there were for that decision. Want to give that a try? Give you 30 seconds on that. How y'all doing? Okay, so let me help you. So for that first decision, when I chose the 8, and these are options, right? We're going to put options on each. Whoop, kind of scribbling away there. Going to put options on each of those. How many options did I have for my first decision? Good job. Only one option, huh? You had to choose the 8. There were no other options. They said I had to start with an 8, huh? Good, good. So for my next decision, how many options did I have? 26, because any letter in the alphabet, right? Next decision, 26. Next decision, 26. Good so far. Then how about when I chose the 4? 10, right? Any digit. The 6, 10, any digit. And then what about the last digit? Just one option because I had to pick the 1. They said it must end with a 1. Does that make sense? So whenever they specify a certain thing in a certain location, that's just one option. You have to do what they're saying. So that's going to be something a little lower. Let me see. Here's the back. So 1757620. So 1,757,600 is how many different options that would give us. Much less, huh? That really cut down on our options. We're under 2 million. The last answer was 158 million. So we cut it way down. See how just a little bit of change like that changes how many different license plates are possible? The inmates that work on the license plates, they need to know this math to get this done. I'm just joking, sorry. So obviously somebody else does this calculation. Questions on that? Is that making sense? We good? Now we can do part C. If you're good with that, let's go on to part C. All right, part C. How many different license plates have no repeated symbols? All the digits are different and all the letters are different. Part C harkens back to the beginning statement, right? The beginning statement applies to A, B, and C. In other words, C does not depend on B. No, you don't have to do anything more about that starting with an 8, ending with a 1. That was just for part B. So we're free of that. That's over. Part C, pick any license plate you want, but there's no repeated symbols. Let me give you a second to think about that. You could get more out of it than if I just whip it out. No repeat. So pick one. Let me encourage you to pick one. Write one down. I'll do one. 8, A, B, C, 3, 4, 6. I picked one. So there's one license plate, no repeated symbols, right? So think back to your options, your decisions and your options. It's all about decisions and options. Make the first decision, second decision, third, fourth, fifth, sixth, seventh. So each of those decisions and how many options. So when I chose the 8, how many options did I have? I'm on part C now, so I'm not doing part B where I had to start with an 8. That was part B. I just did it at random. I mean, I could have started with a 7 there. It doesn't matter. It was not required. So I could have started with any digit there, couldn't I? So there were 10 options. Oh, not the 0 though. Yeah, we're still following the original heading. I forgot about that. Yeah, that original heading applies to A, B, and C. Right? You with me? So I could not start with a 0 then. So I only had actually 9 options, didn't I? I only had 9 options for that first. We can't choose a 0. 1 through 9. Good so far? And then the A, how many options did I have for that? Yeah, 26, right? Any letter? Good so far? Now the next digit, how many options did I have for that second letter? Good, right? Because you couldn't choose A. Remember they said no repeated symbols. So you can choose anything but not A. You have one less option for your letter. You only have 25 options, huh? Is that good? And now when I chose the C, how many options? 24, even one less because I can't choose A or B. Those are taken. Does that make sense? You can't repeat. So there's two things you can't choose. You can't choose whatever letters you chose in the first two spots. You have 26 take away 2, 24 options now. Is that good so far? Is that making sense? Now, when it comes to this digit, this 3, how many options do I have? Now we're changing to digits. We're changing gears a little bit. How many options do I have for that digit right there? Yeah, 9, exactly. Why? Because whatever digit I chose in the first spot, I can't choose that digit again. I'm free to choose 0 now, right? There's 10 digits total, but I've already chosen a digit that I chose in the beginning, and I can't repeat that. So I have 9 other digits to choose from. Does that make sense? And then 8 other digits and 7 other digits, huh? So you see how it goes down 1 every time whenever you're choosing letters or digits in a row that cannot repeat. Because every time you pick one, you have one less option to choose from next time you pick. Right? And so there it would be. Just multiply that together, whatever that is. It's 9. I'm getting 70, whoops, kind of getting sloppy. 70761600. 70,761,600. How are we doing? Just making sense for you? Questions I can answer? Yeah.
Wait, why did you do 9987? Why did you do 987?
Yeah, that's a good question. That's a little tricky. This one was 9 for a totally different reason, because I couldn't choose 0. Right up here, it said the first digit can't be 0. That was the heading which applied to A, B, and C. So that was just because I couldn't choose 0. So I had 9 digits to choose from, 1 through 9, can't choose 0. But right here, why that started at 9 is because at this point I had chosen one digit already. I picked a 7. So when I picked my 3 here, I could have picked anything but 7, because I can't repeat whatever digit I've already selected. So I have 9 options. And then it goes down by 1 each time because I have less options. Every time I pick a digit, I have less options. When I picked this 4 here, I could pick anything except for 7 or 3. I had 8 options, etc. Is that good? Is that making sense? All right, I'm going to leave that behind if you're okay with that. Okay. A set of reference books consists of 6 volumes numbered 1 through 6. In how many ways can the 6 books be arranged on a shelf? It's kind of a funny question, huh? So we have 6 books. 1, 2, 3, 4, 5, 6. They're reference books. So, you know, encyclopedias or something like that, right? Six reference books. And and they're numbered. They actually have numbers on them. There's book number 1, book number 2, book number 3, 4, 5, and 6, right? You know how reference books sometimes do. So anyway, how many different ways are there to arrange them on the shelf? Like mix them up, put them out of order, in other words.
6 factorial.
How'd you come up with that, Isaac?
Because you can only use one book once. So you have 6 options, then 5, then 4.
Nice. I like the way you're thinking. Very, very clear. Yes. Think about, you know, my greatest advice to you would be, like I said, I took a whole class on this, and I learned just do it. Actually, physically imagine doing it. The more it can be real for you, the more you'll sense what to do. Let's actually do it. Say I've got the numbers 1 through 6. I'm going to put them on a shelf. Here we go. I'm going to actually put them on a shelf. I'm going to choose which book comes first, which book comes second, which book comes third. I'm just going to randomly put them in some order. Here we go. I'm going to put book 3 first. Then I'm going to put, you know, this is book number 3. Then I'm going to put let's go book 3, B3. Then I'm going to put book 6. Then I'm going to put book 5. And then I'm going to put book 1. Then I'm going to put book 4. And then I'm going to put book 2. There we go. I just put them on the shelf. So I literally did it. Now, think back. For each of those decisions, I made 6 decisions, right? You make it into decisions, options. How many options? Let's think through it. Real life. This is why this was so helpful to me when I started being more real with this topic. I'm going to say, okay, so if I really did that, I put book 3 here, then I put book 6 and book 5 and book 1 and book 4 and book 2. That is an arrangement. That's one particular. I could have done it many other ways. That's one particular arrangement of the books on the shelf. Then think for a second, okay, how many options were there for my first decision? My first decision, in which I decided to put book 3 first, how many options did I have for that decision? How many different things could I have done there? 6, right? Does that make sense? There's 6 different books I could have put first. I could have put any of them first. And then I chose book 3. Once that decision was made, then I went on to decision 2, and I chose to put book 6 next. How many options did I have for that second decision? Had to be 5, right? Because I could put any book but book 3 next. Book 3 had already been put in slot 1, so in the second slot, I could have done any of them but book 3. I chose book 6. Then for my third decision, you see the pattern. 4 options, because now you've already got book 3 and book 6 in place. You can put any of the other 4, and then 3 options, and then 2 options. When you get to the last spot, you've only got 1 book left. That's why you've only got 1 option, huh? There's only 1 book left. And then you times those together like we always do. And so this is what Isaac was saying is 6 factorial. Remember, yeah, that's right. We did factorial in here already, didn't we? That's 6 factorial. That's 6, 5, 4, 3, 2, 1. And so 120, what is it? 3, 6, 7, 720? 720 different ways to put 6 books on the shelf. Would you have guessed that many? There's, over 700 ways to order books on a shelf. Just 6 books on a shelf. That almost doesn't seem right. All right, now, question B. How many ways can the 6 books be arranged on the shelf so at least 1 book is out of order? How many different ways can the books be arranged on the shelf so that at least 1 book is out of order? Any thoughts? Let me encourage you to do it. I notice I'd just be thinking about, I took a whole class on this, I'd be reading, I'd be thinking, and I'd get nowhere. And then I'd take my pencil, and I'd put it on the paper, and I'd say, Brett, just do one. And I'd do that, and all of a sudden, things would start happening. So do it. Pick some ordering, like I did. I wrote book 3, then book 6, and book 5. I just did on part A, I just did what they were saying. And then then it becomes more real for you when you do that. You can picture yourself picking, and you go, I made a decision. I had 3 options. Then you start thinking about what you're doing and how you had options and things. So think about it. Do what they're saying there on part B. Go ahead and do what they're saying. Arrange the books on a shelf so that at least 1 book is out of order. So go ahead and do that. Give you 30 seconds. That'll help. That tends to help. Any thoughts? Let's do it. Let me do it with you. Maybe that'll help. Let's see. How about doing green? Okay. So I'm gonna put some order. I'm gonna put the books down. How about book 1, book 2, book 3, book 4? They're almost in order, huh? But they told me they wanted at least 1. At least means 1 or more. So then I'll go, okay, book 6, book 5. So that's barely out of order, huh? That's barely out of order. Now, it doesn't have that. That's one way of putting the books on a shelf that's barely out of order. Now, it doesn't have to be just barely. I mean, you could do it really out of order. You could do like book 3 and book 4 and book 1 and book 6 and book 2 and whichever book I'm missing, 5, book 5. You know, that's way out of order. That's fine too. That's another way to put them on the shelf where there's at least one book out of order, right? At least one means one or more. Doesn't have to be exactly one, right? You with me? When it says at least one book out of order, just one or more. So I did it a couple of times. I put them on the shelf where at least one book was out of order. So how many different ways?
719.
Why do you think that, Isaac?
Because there's only one way to put it in order, so you subtract that out.
You seeing that? Is that landing home now? Sometimes the best way, it's funny, I took, like I said, a whole class on this. And this class I took at Cal Poly in my math degree there, it was a junior level class. It was called counting. That was the name of the class, counting. Saturday. I remember looking at the schedule. Back then it was all paper schedules. Back in 1993 is when I graduated. This was probably 90 or 91. Anyway, look at schedule, counting. I'm like, counting? Sounds easy. Counting. How nice. Counting. Junior level, right? Pretty like beyond calculus. Beyond calculus. Calculus finishes your sophomore year. It's beyond calculus, Cal Poly math class. It's supposed to be hard. Counting, it's great. Counting. Signed up for counting. This is called counting. And it was one of the hard. It was not one of the hardest. It was a very hard class. It was very, very challenging. And I noticed it was subtle. It was subtle. Sometimes you got a question like this, and it just seemed impossible until you had a clear thought. And one of the ways you can sometimes have a clear thought is ask yourself the opposite of what they're saying. They're saying, and that's what Isaac and Hector are honing in on, right? How many ways? So that at least one book is out of order. Well, what if at least one book is not out of order? What's the opposite of that? At least, if somebody said to me, hey, Brett, is at least one book out of order? And I said, no. What would that mean? Is at least one book out of order? And I looked at the shelf and I said, no. What does that mean?
It's in order.
They're in perfect order. That's the only way you don't have at least one book out of order. They are book 1, book 2, book 3, book 4, book 5, book 6. That's perfect order, and that is not one out of order. Right? So when they say at least one is out of order, they mean every possible arrangement but perfection. Don't they? Every other way of arranging them, you've got at least one book that's out of order. The only way you don't is if you have perfect. So there's only one way to put them in perfect order. All the other arrangements has got at least one out of order. So if there's 720 total, we just figured that out, part A, right? 720 total ways to arrange the books, and only one of them is the perfect ordering, then how many are not perfect? Well, subtract 1, 719. Right? That makes sense? That's like a silly question when you see it from that perspective. But before you see that, it seems impossible. That's what I did enjoy. I kind of hated the class because it just constantly was hard for me. But when every now and then you'd have a breakthrough and you'd go, oh yeah, that's a simple question when you see it from the right perspective. But until you see it that way, it's not simple. Teacher in that class, Dr. Hood. I had him for several classes. And he gave us the final ahead of time. Just handed it to us. 20 questions, about a week before. And he said, here you go. Here's the he always had a mock. I'm imitating him with a mock. He did. He just mocked us constantly. He just constantly acted like we were all so stupid. He didn't know what our problem was. And so he handed us the final. He goes, here you go, guys. There's like 12, 15 of us in the class, kind of small class. Here you go. Here's the final, 20 questions. 10 of those will be your actual final. I'm not even going to change the numbers. Just figure out those 20 problems between now and next week. 10 of them will be your final. That didn't help. I mean, you'd think it would, right? If I did that, you guys would love it because our questions are a lot easier. Those were hard questions, just 20 of them. I couldn't figure those out. I didn't get an A in that class. They were hard questions. It was just counting, but it was really tricky. Thing was the other day. Okay, so let's try this one. 13P2. So yeah, let's just crank them out in the calculator. If you have your calculator, 13P2, it's button pushing. It's, what is it? Yeah, so it's going to be 130, 26. I think it's 156. Is that what it is? You got it? You guys know how to do it already? So you guys have your calculators? I can probably show you pretty quick. 13P2. There's going to be a button somewhere in your calculator to do this. Let me calculate. I'll show by hand as well. So if you have to do it by hand, here's how you do it by hand. You start with 13 and you do two numbers. So you start with this. So if you have, for those 2 or 3 of you that have to do it by hand, two numbers going down. All these are going down like factorial, like 13, 12, 11, 10. They're all about going down. So you start at 13 and you do two numbers. So 13 times 12. So I started at 13, I did two numbers, and that's it. That's the answer. 13 times 12, 156. Is that good? So that's part A. So part B, 13C2. Now, how's that do? So you have a C button on your calculator, right? You guys should be able to do that. You'll get 75, 78? Know what it is? Those with calculators, isn't it 78? 13C2. Now, here's how you do it by hand for those who need to know by hand. Same thing again. You start at 13. You do two numbers. 13, you know, the first number's where you start. Second number's how many numbers you do. But then the C stands for cut. Cut it by 2 all the way down to 1. The second number. Cut, divide. It doesn't really stand for cut. I'm just making that up, but that'll work. And that'll be 78. So the only difference between the C and the P, for those who need to do it by hand, is they both start at 13, do two numbers, but the C cuts it, divides it by the second number factorial, all the way down to 1, in other words. That's the difference. So then let's do part C. Part C says 13P3. So calculator, you can do it by hand. Try that by hand for those who need to anyway. For those who don't have the calculator that'll do it, try it by hand. So that would be start at 13, do 3 numbers. 13, 12, 11, right? Start at 13, do 3 numbers. I can't do that in my head. What is that? 1076? 1716? 1716. Is that good? Is that what you're getting? Anybody else getting that? Okay. So start at, right, so it's, you start at this number and you do this many. So I started at 13, did 3 numbers. Yeah?
So you multiply all the numbers going together?
Yeah, multiply them. Yeah, it's all, yeah, the times. There's a times dot here. Yeah, multiply, right. It's always multiply. That good? Start at 13, do 3 numbers, multiply them together. And then part D says 13C3. Can you do that one? Try it, and also for the by-handers. Is it 286?
Yeah.
286. Okay, so how you do it? How you do it is you same kind of rules. You start at 13, do 3 numbers, right? But the C, you have to cut it. You have to divide it. Divide it by what? It's the second number, and not just the second number, but the second number factorial, all the way down to 1. Everybody seeing that? So there you go. So that comes out 286. Good on that? Questions on doing that? Now, what in the world is that? P and C and those weird stuff? Well, that's for later. That's for Monday. So we'll give some real life situations in which you need to do it. It's permutations and combinations. It's a probability thing. We better take our test.